So in this task, we were supposed to blink an entity instead of using the high level in which we will be dealing with the mapping of resistors using the CMSIS, which stands for the Common Microcontroller Software Interface System, which is used to directly manipulate the register. So in order to do that, I have created two files. One is the header file and the other is the implementation file, which has the basic code and the other program file, which actually uses both those files in order to implement this blinking project. So let's look into the header file. Header file just deals with the prototype of the function, which means like what kind of functions we are going to be implementing. So it just gives you the initiative, like you're declaring like we are going to be using these particular functions. So just declaring those functions instead of initializing them. So here define the name of the header file and then the basic libraries, and then enum is for enhancing the readability of the code in order to understand. So input mode set to 0, all those things. And then this is for the GPI mode, which means whether it would be the input or output. And then there is the enum for the low state, whether it will be high or low, whether I want the LED to glow or not. Okay, then the port, we have two port here. The A is set to 0 and B is given the number 1. And prototyping those functions, just declaring those functions, and then we will be initializing them. So first is we need to configure the GPIO pin, which is for the input and output. So the port number, the pin number now, it starts from 0 and goes up to 31, and the port number is A and B, and then we have given the value, the value 0 and 1. And then the GPI mode, whether it would be the input or the output, and then we are writing onto it. Basically, after the configuration, we need to write and read the values and start from the and that. So the write has again the port number, pin number, and GPS state, like whether it's on or off. And then the read has the port number, which is A or B, and then the pin. So from A, whether it would be 0 pin, 1 pin, 2 pin, depends on the pin you wanted to select, and setting the, like it's a 32-bit register, so setting the other values among to 0 and that particular pin that you have selected, so turning that value to 1. So here the other helper function is created, like I have set the port number to be port num to be A and B, so setting that value to 0 and 1. So there's another function declared here. Now moving to the actual implementation file, how all these things are implemented. We are going to include the library that we just created here, and then the SAMD21 for the board that we are working with, and which actually deals with the CMSIS. And so the first is the helper function. So if it's a capital or small case A, you are returning 0, and same goes for B, capital B, and small b, it returns 1, and the default value would be always 0. Then we are configuring like whether it's the input or output. So configuration is given, and then the pin number, as I told earlier, like it should be 0 to 31. It couldn't be more. If it's more, then return the value false. The port number, it should be 0 or 1. If it is greater than 1, return the value 0. And then we are masking, like what this line of code does that I talked about earlier, like 32 bits. We want one particular bit to be 1 and other bits to be 0. That's what it does. It changes the mask the particular bit number, like that we need to be 1, and setting other values to 0. And then here we have mode. Now mode generally means like whether it's the output or the input. So in order to do that, we have data direction set and data direction clear. So set actually means like you are actually setting it to be the setting it to be the input, and then the clear actually means you are setting it to be the output. So it depends whatever you're setting, and if it's the input here and if it's the output, then the else condition will be dealing with it. Then I have this input buffer. Now you're setting the value, but you need to read and write. So this buffer is there in order to read and write, and this INEN actually helps to input bit. It enables the input bit. So it actually helps to read and write in the functions. Otherwise, you could get the garbage values. Then here the write function, because we have configured it now, we want to write and read the values in the case of the board. So first the write GPIO, we have the port num, which is again whether it would be A or B, and then it's changed to 0 and 1 using the helper function. Then the pin number and state high or low, 0 or 1. Then it tells like it should be in between 0 and 31, not more than that or not less than that. And then it deals with that. And same goes here. You're writing into it, you're reading the value, it's similar, and then returning whether it's high or low. If it is, then the main part, then which actually tells us what port we are selecting and what pin we are selecting. So using the custom library that we created, and we have the LED port to be A and LED pin 17. Now I have this. This no, yeah. So here, in I'm going to be using the digital pin 13, which is on the Arduino board, and for the blinking of LED, like built-in LED, so that is mapped to the PA17 port A and 17 pin. So that's why you can see the port is A and LED pin is set to 17. Now we are initializing it to be serial communication at the rate of 9600, and after that, like we are telling it like what kind of configuration, it's accessing the values from here, reading those values out, writing those value out, and again writing it and printing on the serial monitor, and it's going in a loop. So what I mean by that is it will be on, then delay for 1 second, which here I have written it 1000, which is 1000 milliseconds equals to 1 second. So that's it will be off for 1 second, then on again, and this how it goes on. So let's. I have already uploaded the code inside it. Let me just open the serial monitor and start it from the very beginning. Just pressing the central button and it will connect. So LED pin configuration successful as the output. LED initialize the offset on off, because I have already told you default value is 0. So on off and seconds. So you can just see it over here. It's blinking. So I've done it with the built-in LED. You can make the circuit onto the breadboard. I have a smaller one, and you can have the LED and register in order to do that. So thanks for watching the video.